Hello guys, I'm Chin. We welcome you all to our YouTube channel, Easy Math with Chin. In this video, I'm going to explain you about linear programming models. So, what is a linear programming model? Absolutely, it's a mathematical model. A mathematical model is a kind of optimization technique. By a mathematical model, we can determine a maximum value or a minimum value of a function under some specific limitations. However, we can divide a mathematical model into three parts. The first one is an objective function. It can be a maximization or a minimization. Second part is constraints, and the third is non-negativity. In linear programming, the objective function is a function with unknown variables, and it is subjected to the set of linear inequalities. Those are the constraints. So in linear programming, this objective function can be profit, production, capacity, cost, or any other measure of effectiveness. The constraints may be imposed by different sources such as storage capacity, raw material availability, market demand or supply. Okay, now let's move on to an example. Then you will undoubtedly get the idea of these linear programming models. If you want, you can write down the problem and try to make a linear programming model on your own. A company manufactures two types of products, P1 and P2. Each product uses two machines, M1 and M2. The processing time per unit of P1 on M1 is 3 hours and on M2 is 2 hours. The processing time per unit of P2 on M1 is 5 hours and on M2 is 4 hours. The maximum number of hours available per week on M1 and M2 are 40 hours and 35 hours respectively. The profit per unit of selling P1 and P2 are $60 and $75 respectively. Formulate a linear programming model. So the easiest way to make a model is to make a table like this to enter the given data. Now let's fill the data into this table. Again, read the problem. While reading, let's enter the data to the table. A company manufactures two types of products, P1 and P2. So let's give one column for P1 and another for P2. Each product uses two machines, M1 and M2. Similarly, let's give one row for M1 and another for M2. The processing time per unit of P1 on M1 is 3 hours and on M2 is 2 hours. The processing time per unit of P2 on M1 is 5 hours and on M2 4 hours. The maximum number of hours available per week on M1 and M2 are 40 hours and 35 hours respectively. So in the next column, let's enter the maximum number of hours available per week. The maximum availability on M1 is 40 hours and on M2 is 35 hours. The profit per unit of selling P1 and P2 are $60 and $75 respectively. So in the next row, let's enter the profit. The profit per unit of selling P1 is $60 and the profit per unit of selling P2 is $75. Now we have entered all the given data into this table. Before going to make a model, we have to decide what should be the objective function. Earlier I have mentioned that there are three parts in a mathematical model. I hope you remember. The first part is the objective function. So for this problem, what should be the objective function? According to this problem, what should be optimized? The profit. With the maximum availability, we need to have the maximum profit. So let's take Z as the profit. And now with the maximum availability, we need to calculate the maximum number of units that we should produce. So let's take x as the number of units of P1 that we should produce and y as the number of units of P2 that we should produce. Now using x and y, we can write the objective function or the profit function like this. Here, the total profit should be equal to the profit of selling 1 unit of P1, is 60, into the number of units of P1, plus the profit of selling 1 unit of P2, it's 75, into y. Y is the number of products of P2. And now let's write the constraints. According to the given details, we can write the constraints like this. So in here, M1 needs 3 hours to make one product of P1. So now we are going to make X number of products of P1. Therefore, it takes 3 into X hours, plus M1 needs 5 hours to make one product of P2, and we are going to make Y number of products of P2. So now it takes 5 into Y hours. And the total number of hours should be less than the maximum availability of M1. It's 40. That's why I put less than or equal sign here. Similarly, you can write the next constraints and then write the non-negativity. Okay, now we have built a linear programming model. I hope you got the way of building a linear programming model. So there are many ways to solve these kinds of linear programming models, like graphical method, simplex method. So in the next video, we'll try to solve this. If you have any doubts, please comment them below, or for more details, you can refer my website. And if you like this video, please click the like button. And if you like to enjoy math, please subscribe to our YouTube channel and click the bell icon. Thank you for watching. See you next time.